record this, and before you take any notes today, I just want you to listen and ask questions so we can make sure we all understand what an improper fraction is and what a mixed fraction is and how they relate, and maybe relate that to a double number line, okay? Because we've been working with number lines. And do you know that, like, in the United States, this idea of using a double number line is a really big 6th grade goal, that you could use it for all kinds of things, which is why we did it for decimals and fractions, and why we did it, you know, the other day when we were talking about equivalent fractions. We did double number lines. And so now we could also use it for improper and mixed fractions. And so a double number, what's a double number line? I mean, what do I do when I use double number line, Kanan?
Well, you put, like, you would, if the improper fraction is like 6/5,
yeah,
then you would put that on the top.
Right.
And then you would put 6/5 below it in mixed fraction.
Okay, so.
And then you would put 1 and 1/5. Perfect.
So let's just start with Kanan's example of 6/5. So I'm going to just make fifths here. So let's I would need how many of these to make a whole? If we're talking about fifths? 5, right? So let me stretch this out. And see, but that's about a whole there.
That's 6. That's 6.
That's right. It's true. That's 6. But I'm going to use Kanan's example. So if that's true, this would be 1 whole here. And this would be 1/5 up here. So there are no impropers yet. So if we just take away these words for a minute and just think about the fractions, this would be 2/5, and this would be what right here? 3/5, 4/5, and this is 5/5 or a whole. But this becomes.
Well, you could do 5/5.
This would be 1 and 1/5. I could do 5/5. You're right, Kyle.
I think that wouldn't it make sense if 5/5 is improper and 1 is a mixed fraction?
Yeah, so up until 1, that's a great question. The words improper and mixed don't really make sense, but still, you could use this idea to help you, once you get beyond 1, to put impropers and mixed. So I agree with you. I would put that up there. Because it's not really reduced all the way, so we would call that an improper.
It's an improper, though.
Well, it's not reduced, right? So what I'm saying is these terms are a little loose until we get past 1. Okay, but I'm going to just have you use these terms just kind of thinking for a minute. Because if that's right, there's really no impropers on the top here until we get to here. And so the first improper fraction is 6/5. Okay, so this is more for you to think about when the improper and the mixed happen. They happen after we get to 1. So from here, 0 to 1, there's no improper and mixed, but afterwards there is. Because that's when we have values that sound like 1 and 1/5, 1 and 2/5, 1 and 3/5. Does that make sense? So the first set of improper and mixed are just these two here. So this is what I would do to make this correct. I would say that's improper, and I would say this is mixed. Okay, so not all of them, but just the top and the bottom of the last 2. So, Marcos, what do you see as the difference of those? Can you describe in your own words? Like, why did you go, oh, what were you thinking?
On the bottom, like 1 and 1/5, like starting all over, but like
Right. You have a whole part, the 1, and then a fraction part. And in the top, so on the bottom, just to reiterate what Marcos said, is The bottom has a whole, the 1, in the part, the fraction, the 1/5. But the top, this one just has a fraction. Okay? Andrew, take your hood off and put that away, please. Okay. So that's the difference. An improper has a whole part with a fraction. And Claire, what about, a mixed has a whole part with a fraction. Well, what about an improper? It's only a fraction. That's it, you guys. Do you see the difference? So Sarah, you want to say that in your own words? The difference between an improper and a mixed?
It's just
A fraction only, right?
mixed is
A whole number with a fraction. Think about the word mixed, you guys. Mixed means more than one thing, right? Like if you, what other kinds of things do you mix? Chocolate syrup with milk, right? You mix it. There's two things, okay? So a mix has to have two different things. It has to have the whole part and the fraction part.
Ice cream and cake.
Sammy.
So then on this, the red numbers on the bottom, what would they be?
So up until, these are considered, everything here, these are just considered proper fractions. So we don't even talk about improper and mixed until we get to 1. So they're just fractions. They're reduced fractions. When they're reduced, they're called proper. So the idea of proper, the idea of improper and mixed, that doesn't happen until you get past 1. Thank you. This is for you. So let's take a look at this next page. So what I'm going to do is, now I think it would be a good time to write some examples down. So get out your binder paper and write the directions. These are the directions you see in your homework. And we're going to use this idea of a number line to write improper and proper. And then we're going to come up with a rule. Okay, so I'll pause while you guys get your paper out. Okay, so as you guys can see, I moved that to the first page so I can make this bigger over here. And I did for a minute. So we're going to use that same idea here to make a number line and figure out how to do 3 2/3. And the directions were change 3 2/3 to a improper fraction. Okay, so that's what we want to do. We want to change 3 2/3. I'll write that out. Right? 3 2/3 as an improper fraction. So if I were going to do that on my double number line, let's see. Kyle, what would I have to break my line into? What kind of fractions? Thirds. And I'm going to go all the way. What's the whole number, Quinn, that's bigger than 3 2/3? The next whole number? 4. Right. So my number line is going to go all the way to 4. Okay? So if my number line goes all the way to 4, Joe, what number would be right here? 2. And then Andy, what number would be right here? 1. And Andy, what about here? 3. Okay, so the next thing is I have to think about breaking my line into thirds, right? So when I do that, I'm going to take each interval. So an interval is just a space between the whole numbers, and I'm going to break them into thirds. So do you see I need to do that everywhere? Does that make sense? Yeah. So, Sasha, between what two whole numbers would 3 2/3 be?
It would
it'd be between 3 and 4, right? And yes, the second notch, right? So it would be right here, 3 and 2/3. So down here, we're going to have the mixed numbers. And up here, I'm going to have the improper. Raise your hand if that makes sense. Okay, so Haleo, what would I put right here? But one's right there, so it has to be a fraction. So look at your jumps. How many jumps are there between 0 and 1? 3, so what fraction goes right here? So look just between 0 and 1, how many jumps did I make so far? Just to get to here. 1. And how many jumps do I need to get all the way to the first whole number? So that's your fraction, 1 out of 3. So this would be what? So we'd say 2/3. And then this would be a whole. And then Claire, in mixed numbers, what would,
1 and 1/3.
this would be 1 and 1/3. So think about it this way, you guys. You do 1 whole jump and 1/3 jump. You see that? Does that make sense? So Andrew, if I thought about getting all the way 1 whole jump, 2 whole jumps, and say right here, what fraction would go right here? 2 and 2/3. Okay, so that's the general idea. So this is a mixed number right here. Okay, what's another example of a mixed number, Sasha?
2 and 2/3.
Right.
Oh, that's already there. I didn't see that.
Yeah, and then what was the goal here? We're trying to write this mixed number, 3 and 2/3, as an improper fraction. Okay, so Kanan, what do you do?
The 3, so in 3 and 2/3, 3, means that each one of those 3's is it's the one that you circled.
Right.
3 and 2/3.
Yes.
The whole number of 3,
Mm-hmm.
each one of those is 3. So for 2 and 3/3, the number that you're dividing it by is 3.
Right.
So every time you take the whole number, you add 3 to 2.
Okay, so let's look at it as jumps. So to get to the whole, there's 3 jumps here, and then 4, 5, 6 jumps here, 7, 8, 9 jumps. So that's what he's talking about. To get to the 3, there's 9 little jumps. So 10, 11. So this says 11 little jumps, and how big is one jump? What size? Thirds. So the improper is 11/3. Do you see that? So the improper counts the little jumps, and the mixed counts the big jumps. So the mixed would count the wholes, right? 1, 2, 3. There's a 3, and then 2 littles. See the difference?
Wait, so we're going to
So your job is to do.
see how many you go to 3 and 2/3?
That's right, because your job was to write 3 and 2/3 as
Oh,
an
I didn't
improper
see
fraction. Okay? Sasha, and then Kyle.
Well, there's another way.
We're going to do the other way in a minute. That's what I want to get to. Kyle, same thing?
Well, I have my own way.
Okay. So let's talk about the other way. I'm not trying to cut you guys off, but I just want to make sure before we do what is sort of a shortcut that you guys understand what the idea is. Because shortcuts in math are great if you understand the idea. They're not so great if you don't understand the idea. Does that make sense? So Sasha, if I had 3 and 2/3, what's the other way?
Well, since the bottom bottom number,
Yes,
the
fraction.
fraction,
Mm-hmm.
is 3.
Right?
So you do the whole number times 3.
Yeah, look at this. So you take these two numbers and you multiply them. And do you know that the reason you do that is because, do you know why you do that?
Yeah.
Why?
Because the bottom number
Uh-huh.
is equal to 1 of a whole number.
So the bottom number represents the little jumps. So there's 3 little jumps in a hole, right? So we're saying we have 3 holes here. So we're going to multiply by how many little jumps we hear. So what's 3 times 3? 9, right? And then what do, Sasha?
You add 2.
Then you add 2. So you do 3 times 3, and let's write that here. That gives you a 9, and then you add 2, and that gives you what? 11. So that tells you you have 11 little jumps. So they're 11 of size 1/3. That's the shortcut. So 3 2/3 on the double number line is the same as 11/3. Does that make sense? Now we're going to practice one more time. Okay, so let's go to this page. We already did example 1. I just moved it over. So let's try example 2. So we're going to do it the long way and the short way. Okay, so it's 2 3/4, and the directions are, let's see, Joe, what are the directions? Okay, so we're gonna, but our goal is to do what? What's it telling us to do? Right, make this mixed number, right, to be an improper fraction. And I don't know if you heard what he said, but you want to get fourths. So if this is 0, and say this was 1, and this was 2, and this was 3, we went the long way, sort of visual. Let's move that over a bit. I'd have to divide each little section into what, Quinn? From 0 to 1, what do I have to divide that up to? Fourths, right? So, and so I would just do that everywhere. And so between what two numbers would you have this 2 3/4? Between what two whole numbers? Where's 2 3/4 going to be on the number line? Between the 2 and the 3, right here, right? So 2 3/4. So, Mark, is this a mixed number or an improper? Okay, so I'll put mixed down here. And then the improper's up here. So try this, you guys. Figure out the improper. What goes right here? So maybe on your paper there, try that. So work it out. What do you think? Pause. Raise your hand if you have it. Okay, good. So who haven't I heard from today? I haven't heard from Jackson. So Jackson, can you tell me what the improper is?
10/4.
Do you guys agree? 10/4? Really close though. Should we count again? 1, 2, 3, 4. Right, that's 4/4. 5, that would be 5/4, right? 6, 7, 8/4. You want 9, 10. What should it be? 11/4, right? Okay, that's going the long route. How many people have 11/4? Okay, now let's just do the shortcut, because really, People use the shortcut all the time. So we're going to take 2 3/4. Yep, it is easy, but you want to make sure you understand it. You're going to take 4 times 2 and you multiply. So what's 2 times 4? 8. And Michaela, then I have to add 3.
So that's 11.
So you get 11 over the little jump size, in this case is 4. Okay, without a number line, let's practice one. No number line, just the rule. Practice. Change 2 4/5 to an improper fraction. Raise your hand when you have it.
That looks like plus 0. Plus 0.
Better?
This is so easy.
Good. Okay, Andrew, what do you have?
14 bits.
Okay, Joe, do you agree?
Yeah.
So, Andrew, what'd you do? He said 14/5. Okay, and how did you do that? Tell me what the shortcut was.
Times 2 is 5.
Right, and you got,
10.
and then what'd you do?
Add 4.
Add 4, and you get 14/5. That's a lot of your homework tonight, doing that. Guess what the other part of your homework is?
Changing that to improper to.
Going backwards, right?
Yeah, that's true.
Okay, so going backwards, Michaela?
Well, like, do we have to do number line for the, like...
You don't have to do a number line, but the number line is how you remember it. Like, your brain will remember it better if there's a picture.
I know, but I mean, like,
Do you have to draw a number line for every homework problem?
no, not like that. I mean, like, do we have to do some of that and some the other way?
Well, your homework is on page 141. So we can look at that real quick so you understand the directions. It does not ask you to do a number line.
Okay.
Okay? Okay, let's go backwards, guys. So I know now you want to start that, but think about how you would go backwards. Who's got an idea? So now we want to do the backwards way. We want to write each improper fraction as a mixed number. So, what do you know, Kanan?
I know that exercise 3
Yeah.
would be 3 3/5.
Okay, so great. He knows the answer. I want you guys to think about it. Over here, we used multiplication over here. And now we're going to do the opposite because we're going backwards. We're going to use division. So count how many 5s go into 18. Count by 5s. 5. Haley. Right. 3. So you know that 5 goes into 18 3 whole times. So if you think about this in a number line, that is weird looking. I know, that was kind of weird looking, but that's okay. If you think about it, if you have fifths, 1, 2, 3, 4, that'd be a whole. 1, 2, 3, 4, that's 2 wholes. 1, 2, 3, 4, that's 3 wholes. So far I have 15 fifths, because that's 5 fifths. You see that? And so 16, 17, 18, this is 18 fifths here. So what we're trying to do is figure out how many sets of 5 are there. So 5 goes into 18 3 whole times. And then what's the remainder? Michaela?
3.
The remainder is 3, right? There's 3 little jumps. So it's 3, and how big are the jumps? What size are they? They're 1/5 size, right? So our denominator is 5. You get that? So last one, we're out of here at 25?
Yeah.
Okay, last one. Let's do, I forgot to put the pen down. The last one is 12 sevens. Okay, so we want to see how many sevens go into 12. Once. Kyle, and what's the remainder?
What's the remainder?
Yeah, we know 7 goes into 12, right? So if we did division the old-fashioned way, 7 goes into 12 once. So what's the remainder?
What's the remainder?
5, right? So it's 1. Remember we already did this in the beginning of the year with decimals? The fraction form?
Oh, yeah.
1 and 5/7. So it's 1 and the remainder. That's in remainder form, but in fraction form it's 1 and the remainder over the divisor. You guys have done that part already this year. So I'm going to stop this and I'll post it on YouTube so you guys, if you have questions, you can look at it.
Will you email it to me?
Do you want me to send an all group email out?
Yeah.
What is